Hi guys, welcome to lesson 12.3, measures of central tendency and dispersion. Our objective for today is that I can find mean, median, mode, and range. So measures of central tendency, these are mean, median, and mode. Outliers are a data value that is much greater or less than the other values in a set, so it's much further away than from the rest of the group. A measure of dispersion describes how dispersed or spread out the values in a data set are. And the range of a data set is the difference between the greatest and least values. So this is what you guys were trying to do when we were talking about range in the functions unit, where we were talking about outputs. In this case, it is the difference between the greatest and least values. All right.
Hopefully this part's a review.
Yep, this should be a review of like 5th grade. So the mean, you take the sum of the data values and divide it by the number of values you added, also called the average. The median is the middle value when they are arranged in order. And the mode is the one that happens most often. So median, middle, mode, most.
A data set can have no mode, one mode, or more than one mode.
There you go. All right, so problem A, or problem 1, we're going to find measures of central tendency. So what are the mean, median, and mode of the test scores below? Which measure of central tendency best describes the scores? So the first thing we're going to do is I write them in order, least to greatest. So we've got 72, 77, 77, 82, 85, 87, 88, 90, 91, and 95. Okay. So the mean, this is going to be calculator work. You're going to just add all of those numbers up
9, 10, and
divide by 10. And when you do that, you get 84.4 is your mean or your average. The median, we look for what is the central number in our data set. So Ms. Zirzo is using a method where she's just starting from the outside and counting in. But we have an even number of data entries. How do we find that median, that middle point? We find the average of the two. So it is going to be 86. And the mode, which data value occurs most often, it would be that 77. So then which measure best describes the scores? As a whole, probably the median gives you the more representative view of everything as a whole.
The mean can be skewed by highs or lows or outliers.
Especially if you have an outlier. The mean can be a very deceiving amount. All right, so problem number 2, finding a data value. We've done a little bit of this in the past when we were solving inequalities and solving equations. But your grades on 3 exams are 80, 93, and 91. What grade would you need to get on the next exam to have an average of 88? So you add the 3 scores up plus the unknown and divide by 4, and that's equal to 88. So in order to solve that, add them together, combine like terms. 264 plus x equals 88. 264 plus x over 4. Multiply by 4 on both sides. 264 plus x equals 352. Subtract 264 from both sides. X is 88. So you would have to get an 88 on your final test in order to have an average of an 88 for the 4 that you took. All right. Now the question is, if the highest possible score on the 4th exam is 100, is it possible to raise your average to 92%? Well, we're going to start off with the same thing. We have our 3 data values. and our unknown, and we're dividing it by 4, we want to know, can we get a 92? So we set it equal to 92. Same thing, 264 plus x over 4 now is equal to 92. Multiply both sides by 4. 264 plus x equals 368 minus 264 from both sides. X is equal to 104. So can you get the highest possible or a possible score of an A? Nope. Sorry.
Should have prepared better for that test.
All right, now we're going to skip C.
We are not.
Okay, so letter C. You guys do this on your own and then check with us. Graham has sales of 1,280, 1,125, 965, and 1,210 for the first 4 days of the week. How much must he have in sales on the 5th day if he wants to average 1,150 for the week? So you add all 4 of your data points up plus the unknown x, divide it by 5, and we want it to be equal to 1150. So when you add those 4 numbers together, you got 4580 plus x over 5 equals 1150. Multiply both sides by 5. You get 4580 plus x equals 5750.
That's what I meant.
Subtract 4580 from both sides. And x is equal to $1,170. Make sure you include that unit. All right. Next up, we have problem number 3, finding the range.
Home on the range.
The closing prices in dollars of 2 stocks for the first 5 days in February are shown below. What is the range and the mean of each data set? Use your results to compare them. So the range, we remember, said the high minus the low. Our highest data value is 47. Our lowest data point is 25. And that gives us a range of 22. The mean, however, we're going to add all 5 of our data points together and divide by 5. We get 21. You're looking at the wrong one.
Oh, I am looking at the wrong one.
160 over 5 is going to give us a mean of 32. Okay, so let's take a look at stock B. We have the high is 36 minus the low of 28. 36 minus 28 is 8. Your mean for this one, you're going to add them all up and then divide by 5.
Huh.
So what can we conclude from this? Well, they have the same average. The same average price of that stock over the course of the week was $32. However, stock B was much less volatile. So if you're looking for something more consistent that's going to make you money over time, stock B would be your choice. Now, if you could somehow play the ups and downs of stock A, you could potentially make a lot of money. You could also potentially lose a lot of money. So for the same days in February, the closing prices of stock C were 7, 4, 3, 6, and 1. The closing prices of stock D were 24, 15, 2, 10, and 5. What are the range? What are the average? And then compare the 2 stocks. Do this on your own, and then check with Mrs. Zerzo and I. So 7 minus 1 gives us a range of 6. The mean is going to be 21 over 5. So the mean is $4.2 on average. Letter D. The range is going to be 24 minus 2, which is 22. And our mean, we add all of those up. and we get 56 divided by 5 is 11.2. So you have a greater value for those stocks, but you also have quite a bit more volatility in it, being that you have a range of $22. It's a pretty significant range considering your highest price was 24. So it almost went to 0, and then it came back up pretty big. So, that's a stock where you got to really wonder what is going on with something like that. All right. So problem 4, finding measures of central tendency. Now we're going to be using some different representations of data. So the line plot shows the number of students in each homeroom at Jefferson High School. Find the mean, median, and range of the data. How do you use that to determine that they're equal? All right, so mean, median, and range. So remember, each of those X's represents one classroom that has that number of students. So 19 students has 4 classrooms. So when you multiply 4 times 19, you get 76. Multiply 20 times 5, and you get 100. 21 times 6 is 126. 22 times 2 is 44. 23 times 2 is 46. And 24 times 1 is 24. So now you can add those numbers up. And it's 416 over, there's a total of 20 data points there. So the average would be 20.8 students. Okay. Our median, we're going to start from the outside and work our way in. And Mrs. Zirzo is just kind of hopping along with her fingers. And what do you know? Our average, or our median, is 21. And the range is going to be 24 minus 19, which is 5. Okay, so we've answered part A. We've determined all 3 of those. Now, how can you use the line plot to determine whether the mean and median are equal? Well, we just find where the mean comes up, see if it's our middle data point.
It's pretty close.
Yeah, it is darn close. Okay. All right, moving on to the next page. We have some more examples of some classrooms. Now, is the mean for Class C greater than or less than the mean for Class A? Now, do we need to even calculate these, Ms. Zirzo? What do you think?
We can eyeball it.
We can eyeball it. So let's just look at Class C and Class A.
We're looking for an average.
Where do we think the average, the middle of the data, is going to be on Class A? Well, I see that it's perfectly balanced, so that average is going to be right in the middle there of 3.5.
This one looks a little skewed to the left.
Oh yeah, that was one of our vocab words from the last lesson, wasn't it? So Class C is skewed to the left, so their quiz scores are a little lower. So Class C is going to be less than Class A. We don't even need to do the math to figure it out. We could just look at the graph.
Love it.
Is the median for Class C greater than or less than the median for Class A?
You have to be the middle.
So the middle number, you actually pushed it up a little high, Jay.
Oh, sorry.
All right. So we're learning.
In the middle over here, I might have to do a little bit of work.
Yeah, we might have to think about this one a little bit. 3, 6. So the median is going to be less than Class A. I looked at the wrong one.
This looks like it's going to be somewhere around 3.5. This is definitely at 3.
Okay. How can you tell which data set has a greater mean by comparing the graphs? Well, let's take a look at it.
What have you done here? Okay.
I answered questions that weren't asked.
Great, that's helpful.
Yes, it is. So, how can we tell which set has a greater mean by comparing the graphs? Well, we can identify that it's going to be class B that has the greatest mean out of all of those. And how do we know that?
It's skewed to the right, higher values.
Yep, it's got many more higher values than any of the others do. So that's going to skew the data to the right. All right, so you look to see where is the data centered at. That's going to tell us where our mean is going to line up. Here, off the screen. Where is the data? Yep. Okay. All right, so that's the end of our lesson for today. Make sure you write down any questions you might have come up with as we went through it, and write down your level of understanding. Have a great night.